Now, you've probably heard lots of people, even myself, talk about how amazing SSH is, or secure shell, and you use that to connect to a remote server, but it's so much more than like telnet into a console to remotely control it. SSH gives you this tunnel, this encrypted tunnel connection to a remote server that you can do all sorts of things. But there's a couple really key ideas that you need to understand if you're going to be using all of the features of SSH. So in this video, I want to talk about setting up public-private key pairs so you can log into a remote server without any passwords whatsoever. I want to talk about using a passphrase or not using a passphrase. And then if you decide to use a passphrase, how you can use SSH agent in order to not type your password or your passphrase constantly. All that stuff is really important to understand, and it can be overwhelming, but we're going to cover it. We're going to set up keys, set up passphrases and agents. It's going to be awesome. So let's get right down to it and understand, first of all, how public and private key authentication works with SSH. Now, if you're not familiar with encryption, encryption has two main parts. There is the private key and then the public key. And this isn't exactly how it works, but you can kind of think of the private key as just that, a key that you can use to unlock a public key. Now, again, it doesn't really work that way. It's more like a signed signature that only this particular key can sign a signature that can be viewed by this public key. And it's kind of complicated how cryptography works. But at the end of the day, when you have two files, you have a public key and a private key, and you want to give away your public key to anyone. It is public. You can put it in your email signature, post it on your website, anywhere, because you want people to know that this public key is something that only you with your private key over here is going to be able to unlock. So you never have to worry about exposing your public key. You want it to be exposed. You want people to know what your public key is. Like I said, put it in your email address, put it or in your email signature, put it on your website. Anywhere you want, post it so that it's publicly out there. And then you have your private key, which again is just a file full of some text. And this private key you never, ever, ever share. And if you're thinking, okay, well, I want to use my private key to log into somewhere else, so I'm going to upload my private key to, if you ever say the words, I'm going to upload my private key to, you're probably not fully understanding how important it is to never share your private key. A private key will only ever live on your computer. If you're putting your private key somewhere else, that is a security risk you don't want to do. You want to have your private key in your personal control on your personal computer, not even on a shared computer that somebody else has root access to so that they could get your private key. And that's something a lot of people don't really think about. Let's say that you are on a system that you have an account on, you log into it, and you might think, okay, I'm going to put my private key in my own home folder, in my own SSH folder, .ssh folder. Here's the problem. Anybody who is an administrator on that computer who has sudo privilege, who can have root access, could go into your folder and get your private key. So when I say never share it, that also means don't put it somewhere that somebody else has shared access to it. Only you can have access to your private key. I know I keep saying that, but it's really, really important. And the reason it's so important is if you have this private key file, you can log in to any computer that has your public key installed. Right. And so that's generally the safest way to secure a computer, is to put a public key on the server and then disable password authentication. So only the private key is able to log in. So that's, again, why you never, ever share your private key. Now, you can have a private key in two different forms. You can have it so that it's not encrypted on your side, like you have personal control of your private key, and so it doesn't require a passphrase to use at all. As long as you have it, boom, you can get right into the computer. But there's also an ability for you to encrypt your private key with a passphrase. And this seems like, when you're using your private key with the passphrase, it seems like you're logging into the remote server by typing your user and password. But that is not what's happening, okay? If you have a passphrase on your private key, all you're doing is peeling off this encryption off of your private key that is still on your computer and then allowing you to use the private key to then log in without a password. You're logging in with just your private key. Okay, so a passphrase on a private key just protects it so that while you should still never share it, let's say somebody did steal your private key. Well, if that private key is protected with a passphrase, they're not going to be able to use your private key to log into a server unless they can also get your passphrase. Okay, so that's just another layer of security. And this is the preferred way to create a private key, is one with a passphrase, so that you have to unencrypt your private key before you can ever use it for public private key authentication. But that's not always the thing that you should do, because if you have your private key protected with a passphrase, that means that you can't use that like in a script to automatically connect to a remote server for like secure copying or anything like that, like a script that you want to do something on a remote server. If you have to type in your passphrase to unlock your private key, you can't use it for automation. And things like Ansible that uses SSH to connect to remote clients, all of those things rely on you to be able to connect to a remote server without you actually typing in either your password or the passphrase to decrypt your key. So there are use cases where you want to create a private key that has no passphrase connection at all. It's just like ready to log in at any given time. But you need to be aware of the security risk that you are opening up by doing that. Okay, so I'm not going to say that one is good and one is bad. It's more like one is a really good idea and one is a really nice idea, right? I mean, which one of those is better? Well, it depends. You know, there's a security risk to not have your key protected by a passphrase, but there are some instances where you might want to do that. So we're going to do it both ways, and then you're going to decide for your situation what's going to be the best option. So if you're the kind of person who learns better by doing, well, you are in the right place, because here I am, I'm on a computer called Test, and then I also have up here in the tab, I don't know if you can see that, but I switched over, and there's another computer called Test 2. Okay, these are two separate servers, and here I am on Test 1. We're going to say this is like my laptop. Okay, if I were to SSH over to Test 2, let's say SSH to Test 2, it's going to do my username by default. So if you actually have a different user account on the remote server, you would do like spowers at Test 2, and it's going to ask for the password. Now this is the actual remote password on the Test 2 server. Okay, I've just logged in using SSH. There's no keys involved at all right now. Okay, I SSH'd over and it said, okay, what is spowers at Test 2's password? So I typed in my remote password, and here I am. I'm now on Test 2 via SSH. Okay, so I'm going to hit exit because I don't want to use my password on Test 2 in order to log in. I want to use those keys. So the first thing we're going to do is actually create the keys. Now, you can use several different encryption schemes and several different strengths of encryption. I'm just going to do the defaults here. So I'm going to say SSH keygen and just press enter. It's going to ask me where I want to save the file. I'm just going to accept the default. And it's going to say, what kind of passphrase do you want to do? This is where I talked about like where it's going to encrypt my local private key. I'm just going to hit enter for an empty passphrase right now. I have to press enter again. Okay, and then it has created my public and private key pair. And if you look up here, it tells us where it put it. So let's actually go in there really quick. It's a .ssh is the name of the directory, so it's hidden, but we can go in there. And if we type ls, we're going to see we have, well, there's 3 files. Known hosts is just, it keeps a record of where we've SSH'd to. So when I SSH'd over to the Test 2 machine, it created an entry in the known hosts file so that we know it's the same server the next time we connect to it. But these are the 2 files. This is the private key, and this is the public key, and you can tell because it's .pub at the end. All right, so let's look at them really quick. Now, again, I'm just making this, I'm going to erase it. This is not a key that I'm going to use anywhere. So I'm going to actually show you what a private key looks like. So ID RSA, this is what a private key looks like. It's just a bunch of text, okay? And it says, you know, the open SSH private key is here. This is all the text. Again, this is something that I would never show anyone, and I would never share the text. I would never share this file with anyone. However, let's clear the screen. We also have the public key in there. So let's look at that one. This one, while also shorter, this is just the public key. This is the thing that I want everybody to be able to see, because if somebody were to put this on a server, I would be able to log into that server even if I didn't have a password or know the password to the account that they put this key into. And I'll show you how that works. First of all, what we're going to do is we're going to use some command line tools to install this key on our server test2. But then I'll show you what it actually does, because it doesn't do anything other than copy text around for us in a convenient way. So if you want to copy this over to another server, you would do, let's just go back to our home directory here. We would do SSH copy ID. And again, since I use the default name of the key here, ID underscore RSA, it's going to use the default name of that one. But if we named it something different, I could do identity and then name the file. Again, I don't need to do that because I'm just using the defaults of everything. So I'm going to say SSH copy ID spowers at test2. Okay, so here's what's happening. It's going to prompt me for my remote password. Okay, because right now my key doesn't exist over there. So I have to type in my remote password on test2 for one last time. And now it tells us what it did. Okay, it said it added one key over to the test2 server. Okay, so, and now it says if you want to test it, say SSH spowers at test2. So let's do that. SSH spowers at test2. Now it should not prompt us for any password because we are going to log in with key pairs instead of a username and password. And that's exactly what happened. Notice here we are on test2, and I did not have to type in my password on test2. It just authenticated by using my private key and comparing it with the public key that we installed. Now, how is the public key installed? Well, I'm glad you asked. On this server, now notice we're on test2. If we go into the .ssh folder, we type ls, we're going to see there is only one file here. Now there's not a file called known hosts because I haven't gone anywhere from test2 to another computer. That's only when you're going to another computer that it creates that known hosts file. But there is a file called authorized keys, and let's look at that. Cat authorized keys. Now this probably looks familiar. This is my public key. Actually, it's all on one line. It did word wrap here, but this is just one line, and it actually copied my public key and put it into a file called authorized keys inside the .ssh folder on the remote test2 server. Now the really cool part is we could add another authorized key in here and just on the next line. So you can have any number of public keys in here. You just like start a new line and put in another key, and you can actually paste them in by hand. You don't have to use the copy SSH ID command. That's just a really nice way to go about doing it because it puts it in the right place and it names it and all that stuff. So this is how it's done. And now let's type exit. We're back on the original test machine. And the nice thing is now any script that we run or that we create can actually connect to it without ever prompting for a login or for a password, right? All we have to do is type SSH test2 and boom, we get right in because of that public and private key pair. Now this is very convenient, obviously, and things like Ansible or anything that you might be using makes it very simple to connect to a remote computer if there's no passphrase. But again, no passphrase means that if we're back on our computer here and anybody were to get a hold of this ID RSA file, they would immediately be able to get into the test2 server, regardless of what we did with the password over there. That spowers at test2, it doesn't matter what that password is because we're not even using that to get in. So it's really important to realize the security ramifications of not protecting this with a passphrase. Now, what I want to do is get rid of everything that we've done. So let's go into SSH. We're going to get rid of ID star. All right, so our keys are gone. Let's go. I'm going to switch tabs over here. So now I'm on the test2 computer. Let's go into SSH, and I'm going to get rid of authorized keys. All right, so now this is here. Clear the screen. Back over here to test machine. Now, if we were to SSH over to test2, it's going to prompt us for the password because there's no keys installed anymore at all. I'm going to hit Control-C because I actually don't want to log in there. But now we're going to create another key pair. This time I am going to protect it with a passphrase. So SSH, keygen, press enter, I'm going to accept all the defaults again as far as file names go, but this time I'm going to put in a passphrase. And this passphrase should be something, complex and long and et cetera, just like a password, but a passphrase, it's just encrypting the local file. So, okay, so now we have another key pair. If we go into .ssh, it looks exactly the same, right? We have a pub key. So let's look at the public key. It looks similar. I mean, it's a different key. We just generated it, but I mean, the same format. It's the same type of thing. But let's clear the screen. If we look at the private key, while it's not a good idea to share this with anyone, if somebody had this, they could not automatically log into my remote server. Okay, and I say that because let's actually try to log in. We're going to say SSH copy ID to spowers at test2. Okay, it's going to ask for my remote password. I'll type that in. And now it's copied it over there. So now if we go back over here, I'm just switching tabs here. We're in test2 now, look in the SSH folder. And sure enough, authorized keys has been created. And if we look at it, sure enough, that's the public key that we just made. But if we go back over here, now when we actually try to log in with our private key, something different's going to happen. SSH spowers at test2. Now it's going to say enter the passphrase. Now notice it's not asking for the password of the remote computer. It's saying enter the passphrase for the key here. This is the passphrase that we created on our local private key. What that means is if we don't know this password, like let me just hit enter, now it's not going to be able to authenticate with this private key, and it's going to say, okay, we couldn't do it with the private key because you didn't know the passphrase, so your only option is to use the test2 server's password. So I can log in the traditional way using a login and password, all right? But, let me hit Control C again, but if we were to do that, and I did know the passphrase, boom, all of a sudden we're in because I've decrypted my local passphrase protected private key. And now we got right into test2 without having to know the spowers at test2's password. Hopefully that's clear. I know that was a lot to take in, but once you understand how public-private key pairs work and the ramifications of protecting that private key with a passphrase, you can make better decisions as to what's going to fit into your particular situation, rather than just following an online guide that you find on Google or something and trusting somebody else's opinion on what makes the most sense. So you can either use a passphrase, not use a passphrase. You can actually use tools to add and remove a passphrase from your private key, so you don't have to keep creating new private keys. But nonetheless, that's how it works. Now, there is one more thing I want to show you, and I know this video is getting kind of long, so if you're not interested in using a passphrase, you can just, hang up the video, you can stop now. But what you can do if you are using a passphrase is you can use something called SSH agent, which will keep that decrypted private key in memory while you're there. So you type in your passphrase one time, and then as long as you stay there, it's going to be able to keep using that without constantly prompting you for a passphrase. And that's honestly one of the best practices if you're doing something like Ansible that needs to connect to a bunch of computers. Is what you do is use SSH agent so that it keeps that in memory, so that all of those subsequent scripts that are going out using SSH to connect to remote computers can use that already unpassphrased private key. So you do it once and it sticks. I'll show you how to do that, and then you will be a professional SSH key person, I guess. So we're back here and we have the SSH keys key pair installed with the passphrase. So if I type SSH test2, it's going to ask me to unlock the thing with a passphrase, type that in, and then we're into test2. But every time we use that SSH key, it's going to ask us for the passphrase unless we get SSH agent running. In order to do that, we would just type SSH agent, and it will go into memory and it will actually give us a list of environment variables that we have to have in memory. This is kind of the most confusing part of it. Here's the deal. When you start a program, it is not allowed to change the environment of the parent shell that is executing the command. it's a very Linuxy thing that we covered in the Linux Essentials course. But basically, SSH agent cannot make changes to your current running environment, but it tells you exactly what environment variables you have to change in order to make SSH agent work. Because the program has to be running, but then there also has to be environment variables running so that SSH knows to use the SSH agent. So it tells you these things here, and we can actually just copy these and paste them in and hit enter. And now our agent is ready to go. Okay. But there's a really easy way that you can do this automatically. Okay. First of all, we're going to kill this as if we were all done and we're going home for the day. All you would do then is type SSH agent -K for kill, and it will kill it off and get rid of all the environment variables. It can unset environment variables. It just can't set them. But here's a really cool command that we're just going to learn. It's called eval. And now what eval does is it takes whatever output happens when you execute a command and it executes them. So all you do is in backticks here, type SSH agent, and it's going to say, okay, whatever the output is from the command that you're running, I'm going to also execute all those commands. So SSH agent was actually designed with the eval command in mind, because if you do this, boom, all of a sudden it executed all of the things that it spit out when we started it. It's just a really shortcut way of putting SSH agent into memory. Okay, so there it's running on our system right now. And if we want to add our keys, we just type SSH add. And again, we're going to use the default, but you could specify if you wanted, but SSH add. And now it's going to have us unlock it. And I have to type my passphrase. Okay, and now that is added into memory, which means it's going to function just like an SSH key without a passphrase. So now if I type SSH test2, we should just get right in without needing the passphrase, and we can do it over and over and over because it will just keep it in memory until we do SSH agent -K for kill. Now, once the agent is killed, if we were to try to go back into test2, it's going to make us unlock that passphrase. Again, I know that was a lot to cover with SSH, but I really wanted you to understand how public and private key pairs work, what decisions you can make, and depending on those decisions, what options you have to make it a viable way for you to connect to remote servers. Now, we're going to do more stuff with SSH too. There's tunneling, there's proxying, there's reverse tunneling. There's really sneaky ways that you can actually get into a network, even if it's completely firewalled off from the outside. SSH is like the Swiss Army knife of network tools on Linux. It's my favorite thing to do, and there's so much we can do with it. And now that you understand how the key pairs work, you're going to be able to kind of get on board with those future things we're going to do. But anyway, I hope that this was beneficial. I hope that you understood what I was talking about, and I just hope that you want to learn everything, do what you love, and most importantly, be kind. I will see you next time when we do more cool SSH stuff.